Benvenuti in questo nuovo video in cui we will take a look about graphs. So there are two ways of solving a graph, and in this example we have to solve with that first. I will show you why, because we have a directed acyclic graph, right? And we have to return all the possible paths from node 0 to node n minus 1. And return them in any order, okay? So essentially we have this data structure, graph I, which will store every node, and graph ij, which is every node connected with, every j node connected to node I. For example, we have graph 1, 2, we have this double list, right? So node 0 in its index 0, and it is connected with j equal to 1 and j equal to 2. So 0 is connected with 1 and 0 is connected with 2, 1, 2. Node 1, index 1, it's connected with 3. Node 2 is connected with 3. So we have to find every possible path from node 0 to node n minus 1. N is 4, minus 1 is 3. So from 0 to 3, the answer will be 0, 2, 3, 0, 1, 3 in any order. And it is returned as a double list. So essentially, what I was thinking about is that we have to traverse the graph. But here, as I was saying, we have to traverse with that first method, because we have to do 0. This is node 0, and we have to access to node 1. But then we have to continue with 1. And then we say node 1, we access here, is connected with node 3. And then node 3, we go here, 0, 1, 0, 1, 2. No. Okay, in this case, 3 is a solution. So we will add it here. Then let's begin again with 2, because 0 is connected with 2. Then 1, 0, 1, 2. 2 is connected with 3. So we add it. Because with breadth first, essentially what we do, we check 0, 1, and then 0, 2. And then we check 0, 1, 3. And then we check 0, 2, 3. Maybe we could also do it. But with that first, we can do the recursive version. So essentially, what we this there is no doubt, so we can start doing list of integer, and we can call it res, which is the solution, and it is a new object array list, right? And then we need what? We need a list of path, no, a list of integer always, of, we call it path, and it is always a new array list, right? And then what I want to do is to call another function, right? With some parameters, then we return the answer, which is res. So we can essentially do a public, because it's public, so a public void function. You don't have to return nothing. Df. So essentially, I need the destination. I need also the current, I suppose, right? For compare them, I need this data structure of the graph, and then maybe we are done, right? So we can essentially do if core equal to destination. What we do? Okay, we need also this, which is our solution and our path. We will add to res, we will add our path. We have at every iteration, like, because how it works at the first, we should have a stack, right? A stack in which we put and we remove object. So essentially we start from 0, and then if it is the correct solution, we keep storing, we add something else, we add something else. But if you won't find the path, we have to remove it. And we have to add on top and remove on top, right? Add, remove. So for this reason, we need something like a stack. A stack essentially is a list. We can use the path as stack, right? So we can do path dot add current. We have to add the current. For example, we add 0. 0 is equal to destination? No. Okay, if it is not the destination, let's look at the childs. So we have to do a for int e equals 0, so we have to, so the child will be at maximum, I mean, graph of e, I suppose, dot length -1 e plus plus, right? And what we do? We have here to add the child. No, we will add here. Maybe we should here add the child. And then we call again recursively. This is the power. So the current will be the current, which is the child in this case, right? No, current will be graph dot I. Maybe here we should put an index I. Index index I. We add to the path the child, and now we check. can call it preb. These represent the node before the current. The father, let's call father. And I are the childs. And then the destination is always the destination, right? The graph is always the graph. Res is always the res. Yeah, we can return. It is a void, so we can return something empty, right? Maybe it can work. So essentially, if it is in the path, if we have completed, we can return, and we will return here. If we return, we go here. Yeah,